Everyone, in this video I am going to explain the concept of data types in C programming language. So what is a data type? So data types are used to determine the type and the size of data which is associated with a variable in C programming language. So you can write a program for doing some computational part in your programming language. So in order to keep your information somewhere temporarily, so you need a space. So now your compiler will reserve a memory for your variables by using this data type concept. So whenever you use data types in your program with the variables, so then only your compiler can recognize what type of data you are going to save in that particular variable, and it will decide how much memory it needs to reserve for your variable. So that is the purpose why we are using data types concept in C. So now we'll see what are the different data types available in C programming language. So there are three categorization of data types are available in C. So the first one is said to be a primitive, and the second one is derived, and the third one is user defined. So primitive is nothing but those are predefined data types, so which is available with your system itself. And then now coming to derived, so we can use your primitive data types and you can form the another type of data type, and those are said to be derived. And now coming to user defined, so user can define a new data types by using this category. So these are the three different types of data types in C. So now coming to a primitive category, so we have the primitive data types are character, which is the lowest data type, and then integer, and then float, double, and void. So we'll see in brief about all these data types a little bit later. So now coming to a derived data types. So I already said derived data types, it can be formed from your primitive data types. So you can use the primitive data type. With the help of that, you can define another data types that are said to be derived. So now array, pointers, and functions will comes under this derived category. And now coming to user defined, sometimes user need to create some data types. So without using all these things, so how means the combination of this primitive and derived data types which we are going to use to form a user defined data types. So enum, structure, union. So these are the concept which comes under the user defined data types. So now coming to primary data types. So in that category we have character, integer, float, double, and void, right? So now we'll see in brief about each and everything. So integer. So integer is nothing but this data type is responsible for storing the data of type integer. And now the memory is reserved for this integer data type. So not only for integer, for all data types, the memory it can be reserved, that can be based on the processor size. That is either you are using 32-bit processor or 64-bit processor, depends on that. The size of data types it can be varied. So now coming to integer, so the memory it occupies, it depends on the compiler actually. So in general, in data type it occupies 4 bytes. So 4 bytes is nothing but 1 byte equals to 8 bits. So in order to store one integer value, it requires 32 bits of space. So now that space is allotted by your compiler when you declare a particular variable of type integer. So now coming to our second category, second data type in this primary data type is float. So it is responsible for storing all your fractions or digits up to 7 decimal places. So we cannot store more than that 7 decimal places by using this float. So it is usually referred to as a single precision floating point type, and it occupies 4 bytes of memory. So coming to a character, so it can be used to store a set of all characters. So you can take any character from A to Z, or you can take any symbols. Everything will comes under the category of characters. So that's what I said, right? It will include alphabets, numbers, special characters. Then it occupies 1 byte of memory. So 1 byte is nothing but 8 bits. This is being the smallest addressable unit of machine, which is containing a fundamental character set. And now coming to our next thing is a double. So it is responsible for storing your fractions as like your floating point. But here the difference is it can store up to 15 to 16 decimal places. After the decimal, you can have a 15 to 16 digits you can display. So it is usually referred to as a double precision. See, for single precision you have 7 decimal places, right? So for double precision it can store 15 to 16 decimal places. And the last one in this primary data type is void. So void data type is nothing but it cannot return anything, means it indicates 0 or non-return value. So it is generally used to assign the null value while declaring a function. So whenever you come with a concept of functions, you want to return a null pointer that we cannot return anything back. So then you can going to use this void data type. So in a primary data types, again we have some other categorizations which we can use a combination with your basic data types like integer, character, double and float. So that will be of signed. So you can represent an integer that may be of a positive value or it may be of a negative value or it will be a 0. So when we want to differentiate that, we can use signed. So signed means it is used to store 0, positive or negative values. You can say some sign. So it is plus 10, minus 15, 0. Like that you can store. And now coming to unsigned, so it can take only 0 and positive values. It cannot take any negative values from your keyboard. If you are trying to give a negative value, it shows some error. So you want to operate with only the positive values, then you can use unsigned data type. So now coming to a long, so it is used to store a large integer values. The size of the long is 8 bytes. So I already explained about an integer. So integer is capability to hold only 4 bytes of information. Now you want to extend your integer to 8 bytes of information it needs to store. Then you can use long int. So I already said you have to use the combination. Like I'll show you in my next slide. So that, and the next one is short. So it is used to store a small integers. So I already said for integer it occupies 4 bytes. I need not 4 bytes of storage for keeping my integer information. I can use short int. So I can save some memory, right? So the short int, it will take only 2 bytes of memory. So see how the combination you can use. So these are the primary data types, your character, integer, void and floating point, right? So these are the primary or primitive data types. So now you can use a combination with sign and unsigned. So character, simply you can use character, or you can use signed character, or you can use unsigned character, right? So these things will be depends on the programmer, means how much memory he required to store his variable. Then depends on that they can choose either simply a character or signed character or unsigned character. So both are all these things will take in the same memory, that is 1 byte, but it will be represented for some positive and negative values. Now coming to an integer, so we have a combination of signed and unsigned. So you can say signed integer, signed short integer, signed long integer. See, you can take the combinations. That's what here it is written. Like signed integer, signed short int, signed long int. So I already said the differentiation. So like integer will occupy 4 bytes, short int will occupy 2 bytes and long integer will occupy 8 bytes. And now coming to signed, it can take all type of values like zeros, negative values and positive values. Now coming to unsigned, so the size of occupying this integer is same. So for integer it occupies 4 bytes, for short int it occupies 2 bytes, for long int it occupies 8 bytes. But only the difference is for unsigned it can operated with the integer values of type 0 or positive values. So it cannot operated with any negative value. So void cannot be used with any combination because it is used for functions for defining the null pointer. And now coming to a floating category. So it's have a float and then we have a double and then we have a long double and then we have a signed float. Okay. I'll show you the ranges, means from what value to what value your data type is going to be stored. I show you in I will show you in last slide. So before that, we will see what do you mean by a secondary data types. So I already said secondary data types, it can be formed by using the primitive data types. So simply see array. So definition of array is it's a collection of data items of a similar data types. Suppose if I want to store 10 integer values, so I cannot take 10 individual variables. Instead of that, I can use only one variable name and I can declare as an array. Simply I can keep my size as 10. So it can store all of values of type integer, or else it can store all of floating point, or else character, or double, or float. So like that means it can group a similar data. Simply we can give like int a of 10. So here you are using your data type integer for framing a array. So like your pointers. So pointers in C are basically a special type of variables actually, and these can be used to store the address of the another variables, and these pointers can keep the information of the same data type. Suppose if I declare one variable of type integer, so I can use a integer pointer to hold the address of that particular integer variable. Okay, so these also define like int star p. So here I am using int, float, char. You can use any data type. And then next one is a functions, so which is the last one, your secondary data types. So these functions is nothing but your user defined functions or predefined functions, like your main function or your sub function, which I am explained in your previous video, right? So whenever we want to group the statements under a single block, and that can be used for a specific task. Suppose if I want to find the length of some object, so now it can find only the length, it cannot do anything, it cannot do more than that. Such type of situations we are going to use the functions concept, and these functions, it may be of two types, that is a user defined and built-in. So built-in is nothing but your library functions like stdio.h, which consisting some functions related to input output functions, right? So like that. And then the last category is user defined data types. So user defined data types of structures, so you can use the combination of both, like you can use your primitive data types as well as your derived data types for defining the user defined data types. So structures which can hold different types of data, so which is reverse of your arrays concept. Arrays can hold similar data, whereas your structure can hold multiple types of data under a single name. So we can access all the data members of your structure by using the structure variable only. We cannot access directly. That is not possible in programming language. Now coming to union, both structure and union is used for the same purpose. Only the differentiation is, so structures can hold the data separately for each and every data member of that particular structure. Now whereas unions, so it is provide a possibility to store different data items in a same memory location. So that's what the difference between structure and union. Now coming to enumeration. So enumeration is nothing but it is also a user defined data type. So which is used to assign a names to an integral constant. Suppose if I define week as my enum, so I can take days. Suppose means every week will consisting some days. So I can assign day 1, that is Sunday with 0. So all the remaining data are assigned with the integer values. It continuously assigned. Like Monday will be assigned with 1, Tuesday will be 2, Wednesday will be 3. Like that it will assign. So for that purpose you are using this user defined data type enum. So we have a keyword enum which is used to define your user defined data type. So now these are the ranges of different data types. Like we have a character. So I already said char is nothing but it can take only 1 byte. So 1 byte is nothing but 8 bits. So how we are finding these ranges is nothing but you can find 2 power 8. So now you can take 2 power 8, 2 and after that 2 square is 4 and 2 cube is 8 and 2 power 4 is 16, 2 power 5 is 32. Right, and 2 power 6 is 64 and 2 power 7 is 128. Okay, so like that it will frame. So it can take 2 power of that particular value. So it can store 256 values, right? 2 power 8 is nothing but 256. So when you are going to use character, simply it can take a positive value, negative value as well as 0 also. For that, 256 is divided as a half. So your positive range will consisting minus 127. So after that it reaches 0 and then it starts your positive values. So because of that, the character, the minimum range is minus 127 and the maximum range is it can hold 127. And now coming to unsigned character, I already said for unsigned character it can operate with only positive values. We do not have any negative values. So here the range it starts from 0 to 255. Now using a signed character we have the same as your character. And now coming to integer, so it will take 2 or 4 bytes, that depends on your processor, whether you are using 32-bit or 64-bit processor. So most probably for 32 and 64-bit processors, the integer size it will be of 2 or 4 bytes, right? So if it is 4 bytes, then it will be the min. If it is 2 bytes, then it will be the range. Okay, so for 4 bytes, it will be the range. Even it will be a integer also, it is the same range as like your floating point. Right, see here, suppose it occupies 2 bytes. So how we can calculate? So it is 2 power 16 you can take, because 1 byte is 8 bits. So 2 bytes is nothing but 16 bits. So 2 power 16 you get 65,536. So that value you get. So now coming to an integer, it can take positive, negative as well as 0. So that's why it is divided as a 2 parts. So in minimum it can take minus 32,767. In maximum it will take 32,767. For unsigned integer also, if it occupies 2 bytes, then unsigned is nothing but it doesn't operate with any negative values. So that it will be a complete range, means 0 to 65,535. Now coming to a signed integer, it's like your integer itself. Short integer, I said it occupies only 2 bytes. So for that you can take the range like this. For unsigned it will be similar as your int, because here also you consider your integer of type 2 bytes. Whereas signed short integer, it can occupy both positive, negative and 0 values. Because of that reason the ranges will be like this. And now coming to a long int. So long int it takes 4 bytes or 8 bytes. Okay, so it takes 4 bytes. So for that it will be the range. So see ones, tens, hundreds, thousand, 10,000, lakh, 10 lakhs, then crores, 10 crores, means 214 crores, 74 lakhs, 83,647. So this is a minimum value it can store. Means whenever you want to store a largest value of type integer, then you are going to use long int instead of simply an integer. Okay, that is the purpose. Signed, it can take only the one range. So we can add these two and you can get this range. For unsigned long int, it will be the range of this. And floating point, so we already defined like floating point means it will take after decimal places. It can give 7 places and that is taken as an exponential value. That is 3.4 exponential of 38. So that's what the range means. That for the precision, it will take 6 digits of precision. So that is a range of float. And now coming to a double, it is 1.4 e power 38. So that is 2 and 1.7 e power 308. It can hold the values like that. You can give a long double. So which you are trying to keep a largest floating point values, you are going to use double and long double. Otherwise, you can simply use your floating point. That is enough. Okay. So please do like, comment, share and subscribe my channel. Thank you.